Okay, so today what I want to do is I want to go through and do some basics of factoring. So the basics of factoring sound like this. So the first thing we're going to do is get into our 7.4 note packet. And I want to look at 13 as our first example, but let's write down some rules. So the first rule that we need to look at is that you are using division to find the greatest common factor. So basically you're looking for the greatest common factor and then you use division to take it out. So you're going to use division to remove the largest common factor. Okay, and we're doing this without creating fractions. And it's important that you understand the second part because I could pull anything out, but then you would have a fraction. So keep in mind that when you're doing this, you are trying to make sure that you do this without causing fractions. Okay, so the second rule is going to be real simple. If there are variables, okay, and those variables are the same. So what I'm talking about is if you have like an x and an x squared and an x cubed, they all have x's, but their exponents don't have to be the same. Then you will remove or will factor out the lowest exponent amount. So what I'm saying here is if you have like an x cubed, an x squared, and an x to the fourth, you're going to look at all three of the variables. Now, all of your terms have to have this variable. You can't just pull it out of the first two and ignore if the third one doesn't have it. So if all of the terms in that polynomial has an x, then you look for the smallest exponent. If that lowest exponent is, in this case, it's a 2, then you can pull a 2 or factor out a 2 out of all three of them. Okay, so enough about the rules. Let's kind of go through some examples. So like I said, we're going to start off with number 13. So 13 is 6x squared plus 3x. So really this is quite simple. What we're going to do is stay with the numerical coefficients first and then talk about the variables. Now remember, a numerical coefficient is very simple. It's the number in front in each term. So in this case, I have a 6 and a 3. We look at it and say, what do they both have in common? Well, they both are multiples of 3. So we're going to divide out a 3. Then I go, okay, do they have anything else in common? And we look at it and go, oh yes, they both have x's. So we find the lowest exponent amount, which in this case is an invisible 1. So it can only take out an x to the first. So now that I know what I'm going to divide them by, to actually get your final answer, you're just going to rewrite what you're going to divide it by out front. And then you do your division. 3x divided into 6x squared. Well, 3 into 6 is 2, and x into x squared leaves me 1x behind. Plus, if you notice, 3x and 3x are the same. So that's going to divide out and make a 1. So your final answer is 3x parenthesis 2x plus 1. All right, so let's look at something that maybe has a little bit bigger exponents to pull out. So number 14 is 4x to the fourth minus 20, I'm sorry, they were y's, 4y to the fourth minus 20y cubed. So in this case, it's pretty straightforward like the first one. We know that 4 and negative 20 both have a 4 in common. So we just pull out a 4. Now we must look and see, do they have the same variable? And yes, they do. They're both y's. So since they both have y's, we look at the smallest exponent. And in this case, we both have a cubed. So the greatest amount that I can pull out is a 3, which is always going to be the smallest exponent. Once again, whoever's in the denominator is what I'm going to put in front. So 4y cubed, then actually do the division. Well, 4 divided into 4 becomes 1. Y cubed divided into 4y becomes just y. Minus, because the negative and positive don't change each other, so it stays the negative. 4 into 20 is going to be 5, and the cubes drop themselves off. So your final answer is 4y cubed, parenthesis, y minus 5. All right, let's do one more, and then we'll talk about taking it the next step. So, looking at number 17, and let me push my paper up a little bit here. Number 17 is 24h cubed plus 8h. So once again, we look at it and notice that 24 and 8. Okay, now I know in number 14 we looked at it and said, oh, they both could have been even, but then even you would have noticed that 4 came out of 20. Well, in this case, a lot of times, even though we know 8 goes into 24, sometimes we get this wild idea that, oh, I can pull out a 4 or just a 2. Remember, we want the largest common factor. So the largest common factor is the 8 in this case. Now, once again, where is your smallest exponent? It's attached to the 8, so we're only going to take out an h. So remember, taking out or dividing, that means we're going to put that out front. So we end up with 3h squared plus 1. So that is my final answer. Now, if you look through the packet, I want you to complete the rest of the problems in that section. So we're looking at problems 13 and 14 are done, so 15, 16, and 18 complete on your own now.